Hello, friends. MoNaCo again. Our third lecture in organic is about alkenes and alkynes. In our second lecture, we got into the homologous series of hydrocarbons. And we looked at just the simplest hydrocarbons, alkanes. No double or triple bonds, pardon me. It's all single bonds between the carbons. So now we're going to take it up a notch, talking about the chemical compounds that have double and triple bonds in more detail. We had just named some single bonded carbon atoms in the last lecture. We're going to talk about naming some branched alkenes and alkynes in this lecture. So homologous series also shows carbon compounds with double and triple bonds. How do we name these types of hydrocarbons? So we saw in the last video how we found the longest chain of hydrocarbons, and then we numbered and named all the branches that came off of it, and all of them that had single carbon-carbon bonds got the alkane like suffix ane. We're going to talk about alkenes and alkynes now and how we show which carbon the double and triple bond is between. So aliphatics is just chains and rings, chains of alkanes, I'm sorry, hydrocarbons are alkenes. We're talking about double bonds, which make them undersaturated. General formula is CnH2n. So we always have twice as many hydrocarbons as hydrogens as carbons. They always have their names that end in "ene." And N means, when you say an N-alkene, it means it's just like a straight chain alkene, and the double bond is located at the one end of it or not. So N-propene, 3 carbons, C3H6, and it would look like this. N, because at the end of the molecule is where you have the double bond. When you get more than 3 carbons in the alkene, you have to tell the number, the carbon number that the double bond is between. Straight chain alkenes. So, same rule. You count the number of carbons, use that as your prefix. Then the suffix is going to be ene this time. And the only other thing we have to do is we have to tell us where the double bond is. And you always want the double bond to be closest to the beginning of the chain. So if we number our carbons, we got 5 carbons. So that's pent. And there's a double bond in there, right there, so that we know that it's an ene ending. So the only thing we have to do is say that the double bond is between the second and third carbon, so we just say 2-pentene. If it was between the first and second carbon, we call that N-pentene. Now, when you have doubles, meaning if there's more than one double bond in your molecule, the name is going to have diene at the end of it. Okay, but the whole idea is we always start with the same name number, the chain. 1, 2, 3, 4, 5 carbons. So that's penta. Since we have 2 double bonds, it's going to be diene, pentadiene. Let me write that. Pentadiene. And now we just have to say where those double bonds are. And we can say 1, 3. 1, 3 pentadiene. Because the first carbon and the third carbon are the ones that have the double bonds on it. Penta, because there's 5 carbons in the longest chain. And diene, because there's 2 double bonds in there. Diene. So 1, 3 pentadiene. So branched alkanes, we put the branched prefix first in the name. Parent chain comes last in the name, along with the number of where the double bond is located. So, again, find the longest chain, number it, and use that as the base of the name. The branch, you tell the number that the carbon's on and how many methyl or ethyl or carbons are in the branch. So let's see here. We've got 1, 2, 3, 4 is the longest carbon chain. Yep, and we want to start so that the double bond is and the branches are at like the front end of things. So we'll call this 1, 2, 3, 4. So there's 4 carbons in there. So the base chain is but prefix. We have 2 branches and 1 double bond. So the branch prefix comes first in the name, parent chain comes next. So the branch comes first, so we'll say 2, 3 di for 2 dimethyl, I'm going to move the but there because I got to put the number for the carbon in there. 1 but, and the suffix, because it's got a double bond in there, ene. So 2,3 dimethyl 1-butene, or N-butene. 2,3 dimethyl N-butene. Kind of complex stuff. Again, you're not going to get these straight off the bat. You're going to have to follow along in class practice to really start to understand how these naming rules work. Let's talk about alkynes. There's nothing different between alkenes and alkynes except there's a triple bond and the general formula is slightly different. Naming them, it's all going to be the same except that we use the suffix yne for ine. So examples involve straight chains, aliphatic alkynes. You, again, number the longest carbon chain you can find. Find the prefix for the parent chain, meth, eth, prop. And then you find the suffix related to the number of carbon-carbon bonds. So this one's prop triple bond, YNE. And since the triple bonds between the first and second carbon, you could call that 1-propyne or N-propyne. I would call it 1-propyne myself. Now here we've got another one. It looks different, but that's because it's on a slant. 2, 3, 4 carbons. So our base parent chain is going to have a but suffix for 4 carbons. We know that there's going to be a YNE because of the triple bond for YNE. And then we have to put the number of the carbon that the triple bond starts on. And in this case would be 2. If you did 3-butyne, that would mean that it's between the third and fourth carbon. If you did 1-butyne, that would be between the first and second carbon. So there we go. Only need to include a number for the bond location if there's more than one possible location. I guess that's a technicality that we're really not going to get into. So let's look at a couple examples here. Always, always, always name the longest chain first. Put the triple or double bond and any branches as close to the front of the chain as possible. You can name from either end. It looks to me like this one's symmetrical, so I'm going to go like this. 6. So I got 6 carbons in the parent chain. So meth, eth, prop, but, pent, hex is going to be the name of my parent chain. It's got a triple bond in it, which makes it part of the alkyne series. So it's going to be hexyne. Now, there's no branches here, so I just have to say which carbon the triple bond starts on, and it's the third carbon, 3-hexyne. If you started numbering from the other end of this chain, since the molecule is symmetrical, you would have gotten the same result. Second example, we got, looks to me like a 4-carbon chain. I'm going to start numbering from the carbon that puts the triple bond closest to the front of the chain. 4 carbons means my parent chain has the but prefix. Then we know there's a triple bond there, so that's got the YNE suffix. There's no double triple bonds, so it's not diine. Doesn't really happen too often. And then we just have to tell it which carbon that triple bond originates or starts on, and this is the 1-butyne. You could use the letter N for normal butyne as well. Now let's see if we can take what we've been doing in one direction and go the other direction. 2-pentyne. Pent means I've got 5 carbon. Ine means I got a triple bond. bond. And the 2 means that it's between the second and third carbon is where I have that triple bond. So let me draw a 5-carbon chain. I'll start with the backbone. 5 carbons. Between the second and third carbon is the triple bond. And I fill everything else up with hydrogen so that there's 4 lines or 4 bonds that each carbon makes. This carbon in the middle gets no additional hydrogens because it's got 1, 2, 3, 4 bonds. This carbon in the middle also, same story. No more hydrogens because carbon can only support a total of 4 covalent bonds. So there we have 2 pentyne. See what we got in the next page here. Branched alkynes. So we branch prefix comes first in the name, parent chain comes last, along with the number of where the double bond is located. So 2-methyl 3-pentyne. So here's the parent chain, pent, 5 carbons. Yne, we got the triple bond between the third and fourth carbon. And on the second carbon, I have a methyl. That's 1 carbon group on the second carbon. So I start by drawing a backbone of 5 carbons. 1, 2, 3, 4, 5. Between the third and fourth carbon, I have the triple bond. So between the third and fourth, I have the triple bond. So that part's checked off. That part's checked off. Now I have to just show that on the second carbon, I have a methyl group hanging off of it. Methyl for the meth for the prefix 1. And then I fill up all the other spots with hydrogen. I saturate everything else that I can. And I don't put more hydrogens on those 2 in the middle because those carbons are already full with their number of covalent bonds. Second example, let's try and name this one. So, yipes, find the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons is the longest chain. So I have my prefix for my parent chain is NON. Now I look and see, okay, where is my triple bond? It's between the 5th and 6th carbon. So I can say 5, and it's a triple bond, so I can say YNE, no 9. Now I just have to deal with these 2 chains that are hanging off there and there. Well, the chain that's hanging off the third carbon is 1 carbon long, so that's a meth prefix. And the chain that's hanging off the 7th carbon is 1 carbon long, so that's also a meth prefix. So instead of saying 3-methyl, 7-methyl, 5, no 9, we can say 3, 7, dimethyl, 5, no 9. Very complex examples in our notes. In our practice, you're going to see some more down-to-earth kind of examples. If you looked up the names of all these things on the internet, you can find out what they're used for. Honestly, I don't know what the most of these are off the top of my head. They're aliphatic hydrocarbons. They're probably a product of crude oil production. Let's go with a name to a structure. So we start with the second part first. Bute, 4 carbons. Yne, a triple bond. Triple bond. It's between the first and second carbon. And then on the third carbon, carbon number 3 has a 1 carbon branch. That's how I'm interpreting that name. 4 carbon parent chain. 1, 2, 3, 4 carbons in the parent chain. Check. I got to put the triple bond between the first and second carbon. Check. And the carbon number 3 has a 1 carbon long chain. And we fill everything else up with hydrogen. This carbon only gets 1 hanging off that end, and this carbon gets no additional hydrogens. Okay, so carbon 3 has one branch. Fourth example, I want you to try this fourth and fifth example yourself. Remember, start here to find your chain. This is the chains, and this is the branches. The branch is in front, and the chain is in back. So start with the chain, and then put the branch on it. Now, I understand you might be like spinning your head going, I have no idea what's going on. But the great thing about YouTube lectures is you can always pause and go back. So I want you to understand how to name some basic alkenes and alkynes using the chain, longest chain, identifying where the triple bond or double bond is, and then identifying if there's any branches off that longest chain, and calling them out as to where they are. So there were 6 practice pages in our packet. So at this point, let's work through those in the class. Okay, got to do examples, got to follow along, got to understand what these naming rules are. There's a prep quiz and an actual quiz related to aliphatics, homologous series, naming the basic hydrocarbons. Okay, so thanks for watching this longer video. Just had to be done.